China just revealed something straight out of science fiction, a laser system so advanced it could redefine global defense technology. The newly unveiled LY-1 laser can disable drones, intercept flying threats, and even safeguard naval fleets using nothing but concentrated light. But this isn't just a new gadget. It's a technological leap that could change how nations think about security and energy efficiency in the years ahead. So, how did China reach this level, and what does it really mean? China's unveiling of the LY-1 high-energy laser marked a turning point in its technological strategy, blending science, precision, and national ambition. Displayed publicly during the September 2025 Victory Day event, the LY-1 stood as a gleaming emblem of what Beijing describes as clean, continuous, and precise defense energy. It was mounted on an 8-wheel transporter with a large optical turret resembling a futuristic telescope, capable, according to Chinese sources, of neutralizing airborne objects instantly with a focused beam of light. Unlike traditional defense systems that depend on missiles or gunfire, the LY-1's principle is different. It operates at the speed of light, meaning there's virtually no delay between detection and response. Once the target is locked, an intense beam of energy travels directly to it, either blinding sensors, disabling propulsion systems, or burning through small drone surfaces without any explosive reaction. Experts describe this as precision neutralization, designed to intercept threats in a controlled, environmentally safe way. The system reportedly combines high power generation with adaptive optics, technology that corrects distortions in the atmosphere to keep the laser stable across long distances. Its range is believed to exceed several kilometers, though exact figures remain classified. Engineers behind the program claim it can run for long periods without major maintenance thanks to advanced fiber optic cooling and energy recycling mechanisms. This efficiency sets it apart from early prototypes like the Silent Hunter, a smaller vehicle-mounted laser that once required bulky cooling units and had limited endurance. China's focus has now shifted toward compact, self-contained systems that can function on ships, ground platforms, and even autonomous vehicles. These systems are designed not only for precision targeting, but also for surveillance, communications, and satellite calibration. The LY-1 thus represents the culmination of over a decade of directed energy research, signaling that China intends to lead the global race for sustainable, low-cost energy-based security technologies. The true test of any new system lies not in parades or laboratories, but in real-world conditions. After its public debut, China's laser technology began transitioning into active demonstrations across various terrains, from coastal defense platforms to high-altitude testing zones. Reports indicate that the LY-1 and its derivatives were evaluated under conditions of heavy humidity, sand, and extreme temperature fluctuations, proving they could operate continuously without overheating or optical drift. This adaptability is what gives the LY-1 its edge. Traditional systems suffer from thermal bloom, where atmospheric heat scatters a laser's intensity. China's engineers claim to have solved this problem using a new composite mirror coating and automatic beam modulation. In simple terms, the laser adjusts itself mid-flight to maintain a focused point on the target, regardless of weather interference. Tests reportedly showed consistent accuracy within a few centimeters, even when aimed at fast-moving drones. Another advancement is the weapon's environmental endurance. A research team at the National University of Defense Technology recently revealed a smaller 2.47 kilowatts laser variant capable of operating from -50 degrees Celsius to +50 degrees Celsius without external heating or cooling systems. That achievement shows a push toward rugged, portable designs suitable for deployment in both Arctic and desert climates. Unlike massive energy installations, these systems are compact enough for quick relocation, allowing rapid response to potential airspace intrusions or emergencies. Outside its own territory, China has begun showcasing these directed energy technologies to partner nations during joint exhibitions and science fairs. Analysts see this not as aggression, but as soft power outreach, offering cleaner, faster, and more sustainable protection systems. In effect, China is promoting laser defense as part of a new ecosystem of smart deterrence, where precision replaces escalation and light replaces combustion. China's success with high-energy lasers reflects more than technical progress. It highlights a broader shift towards sustainability, efficiency, and precision in modern security design. The LY-1 represents a new kind of power equation, one where energy replaces ammunition and where precision can prevent unnecessary destruction. The cost per use is dramatically lower than that of conventional interceptors. As long as the power generator runs, the laser can continue operating without the logistical strain of resupply. This shift changes how nations may think about defense investment. Instead of stockpiling physical weaponry, they might focus on scalable energy sources, rapid cooling technology, and AI-driven tracking systems. China's leadership has already framed directed energy development as part of its new industrial energy strategy, linking it to civilian technologies like fiber communications, renewable power storage, and atmospheric optics. That means innovations from the LY-1 program could later enhance telecommunications or space-based energy transmission. There's also a strong diplomatic dimension. By presenting its laser systems at international expos and collaborating with partners in Asia, Africa, and the Middle East, China is positioning itself as the global provider of next-generation defensive technology. This mirrors its approach in electric vehicles and green energy exports, using innovation as a bridge for cooperation. The LY-1 and its spin-offs could eventually become part of cooperative security frameworks or dual-use scientific missions, such as protecting satellites from microdebris or managing high-altitude observation stations. Meanwhile, other nations are accelerating their own programs, sparking a healthy competition in efficiency and safety. Instead of an arms race defined by destructive capacity, this emerging contest revolves around accuracy, cost-effectiveness, and control. The focus is shifting from escalation to prevention, from reacting to predicting. And lasers, as controllable beams of energy, fit perfectly into that paradigm. From a strategic perspective, the real story is about control over energy itself. Whoever masters efficient, directed energy systems will command a crucial part of future technology infrastructure, not through domination, but through innovation leadership. The LY-1 is therefore more than a prototype. It's a symbol of how scientific breakthroughs can redefine what security means in the 21st century. China's progress in directed energy research demonstrates how light, once only a symbol of discovery, is becoming a tool of precision and protection. The LY-1 and its successors blend engineering, environmental awareness, and forward-thinking design in a way that captures the future of sustainable security. It shows the world that technological leadership doesn't have to rely on brute force. It can rely on brilliance, innovation, and precision. The age of light-based defense has arrived, and its impact will illuminate the path ahead for decades to come.